In this video, we are going to check the subscripts in Swift programming language. Classes, structures, and enumerations can define subscripts, which are shortcuts for accessing member elements of a collection, list, or sequence. You use subscripts to set and retrieve values by index without needing separate method for setting and retrieval. You can define multiple subscripts for a single type, and the appropriate subscript overload to use is calculated based on the type of index value you pass to the subscript. Let's take an example. Before that, let us check the syntax of subscript. A subscript with the index with type can have any type and have any return type and provide getter or and setter. This is the syntax of a subscript. Take an example. Struct timetable. Let us create a constant. Multiplier of type integer. Then the subscript, which takes a single parameter of type integer and also returns a integer value. Here the getter and setter. So in getter we return the value return. So multiplier, we need to calculate the multiplication. So the multiplier into index. In this example, we don't have any setters, so just remove that. And let us check the result. Let 3 timetable is equal to timetable of multiplier. So we are checking with 3, put the value as multiplier as 3 and print 3 timetable. So we are going to use the subscript by using this simple. So this is step 1. What is result? Will be 1, will be 3 and 5. This will be 15. In this case there is only one line, so we can just put the return statement only. It will work also. So this is how the subscript is working. There are some subscript options are there. Subscripts can take any number of input parameters, and the input parameters can be of any type. We can also return any type. Like in this example, we returned the integer. Can use variadic parameters, but we can't use the in-out parameters and can't provide a default parameter value. Let us check a big example. As you know, the matrix operations, we are just going to create a matrix using the subscript. So structure called matrix. There are rows and columns, so we declare two properties, rows of int and column columns integer, and to store the value I am going to declare a array of type double var the name grid of array of type double. And initializer, we need to set the rows and columns. For that, first param is rows type int and columns of type int. We set the value this dot rows, self dot rows is equal to rows and self dot columns equal to column columns. Okay, then also we need to declare the array, initialize the array. Grid is equal to array. So we are going to create an array of having length the multiplier of rows and columns and filled with the value of default value of 0. So we can use array literal this function repeating with 0.0 and count will be rows into columns. Okay, good. So next I am going to create a method, going to declare the subscript. Here we are going to call the array like this, var matrix is equal to matrix of rows, for example 2 and columns 2, and I need to get the values like matrix of 1 1. Okay, for that I am going to create the subscript that will have two parameters, rows and columns. So row of type int and column of type int, and that will return the as double. Okay, so we have an getter and setter. So in the getter I need to return the required value. So return grid of row into column plus column. Okay, and here we set the value like grid of row into column. Is equal to new value. Okay, so work good. So print the value matrix of 1. So put the value of 3. Good. If you want to provide any value, the value will be default 0. Okay, so in case when I put a large number, it will show is compile time error. So we can check here if it is a valid row or column. For that I am going to declare a new function. For helper function, the index is valid, a row and column, till return boolean true or false. Return if the row should be greater than or equal to 0 and row is less than number of rows. Same ways, column should be greater than 0 and column should be less than, so column should be less than columns count. We can put an if case. Instead of if case, we can assert it, like assert condition and message. Assert index is valid of row and column, then put a message index out of range. Good. Same way like here. Let us run here. See, we got the assertion failed message, index out of range. Here also, when getting range. Okay. So a class or structure can provide as many subscript implementations. The appropriate subscript to be used will be inferred based on the type of the value or values that are contained within the subscript brackets at the point that the subscript is used. This definition of multiple subscripts is known as subscript overloading. We can also define a subscript with multiple parameters. So we have checked the subscript of an instance. So that the instance subscripts are subscripts that you call on an instance of a particular type. Got it. So next we are going to check the type subscript. The subscripts that are called on the type itself are called a type subscript. Num planet of type int, the case query value 1, then minus Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Okay, I am going to declare a type subscript. For that, static subscript of type int and return type int. So return planet. So we can return planet oneself, planet of raw value n. Okay, so just call planet of int 3 or 4. 4 is what? 1, 2, 3, 4. Mars, I can do Earth. let value of type is optional, right? Unwrap it. Okay, earth. So this is a type subscript. So use of that static keyword. We can also use the class keyword, which is actually used in the classes to allow subclass to override the superclasses implementation of the subscript, like we seen in the methods. Okay, that's all about the subscripts. Thank you.